Today we'll be looking at sleep disorders. In the textbook, this is page 158 to 159. Today, in our essay, we'll be looking at and discussing the different explanations of insomnia, narcolepsy, and sleepwalking. These will be the only three conditions we'll be including in our essays. Now, as a nice little introduction, I've always included BUSCEMI et al. In 2006. Why do we like BUSCEMI? Purely because he is a modern researcher at 2006, as well as that he introduces the idea of sleep disorders very nicely for us. So he defines a sleep disorder is when an individual has lower quality of sleep, which leads them to either an impaired functioning of sleep, which we know as insomnia, or excessive sleepiness, which we'll know as narcolepsy. Sleep disorders place a burden on society for the severe conditions due to the individual suffering from a lower quality of life, safety worries, productivity will also be impaired as a result. So the reason why we like this particular quote that I've got here is that we can pull certain portions of this. When we're discussing the explanations of sleep disorders, this is the crucial part, the fact that these are very real disorders and they can have a very huge impact on the individual's lives. For example, if we're looking at narcolepsy and the different quality of life an individual can have there, there will be huge amounts of worry about them leading a normal life to an extent, because they will have bouts of sleepiness which could lead to them obviously being injured, and as well as that potentially putting their lives in danger as a result. Now, as mentioned, the three disorders that you'll be using within your essay are insomnia, sleepwalking, and narcolepsy. And throughout this video, I'll be breaking the different explanations down for each one of these. Now, within this essay, you just need to explain the explanations and you need to evaluate them by saying whether or not this is a worthwhile explanation for this particular disorder. The first disorder that we'll be looking at today is insomnia. Now, insomnia, as we can see on the image there, is when an individual suffers or has the inability to get to sleep. So there are different forms of insomnia and they've got different varying lengths, which we'll be looking at now. Now, PROVINI et al. In 1994 defines insomnia as the following. We've got transient insomnia, which lasts less than 1 week. So, for example, those of us who get stressed during an exam period and have got the inability to get to sleep, transient insomnia is what you experience. And short-term insomnia, which is 1 to 4 weeks. Then we've got chronic insomnia, which lasts more than 1 month. And interestingly enough, between 10 to 35% of the population in the Western world have suffered from chronic insomnia. Now, in lesson, we had an interesting discussion about this. Maybe this is a result of the huge amount of light exposure that we've got going on in our world with this 24-hour culture. As we know, with the likelihood of even artificial light, that it can impact on our sleep patterns. It can inhibit the production of melatonin, which makes you less likely to go to sleep as a result. Now, PROVINI et al. In 1994 provides us with 2 types of insomnia. Now, these have got varying reasons as to why the individual has developed the insomnia. And they're broken down in primary and secondary insomnia. Now, primary insomnia, the pathogenesis, so the reason for the insomnia is unknown. However, it has been linked to hyperarousal. Now, hyperarousal is when the individual's got that inability to calm down and settle down. And because they can't settle down, they won't be able to get to sleep as a result. And this was found by Bonnet and Arndt in 1995, which is obviously supporting PROVINI's explanation for primary insomnia. While secondary insomnia has been contributed to several elements within an individual's life. One element is poor sleep hygiene. So those of us that don't know or can't remember this, these are rituals before you go to bed. So for poor sleep hygiene, if you drink coffee, or you watch TV, or you read your phone before you go to bed. These are elements which are considered to be poor sleep hygiene, which will then lower the quality of sleep as a result. With secondary insomnia, they also take into account other underlying medical conditions. So there may be another medical condition which is causing the insomnia, which is obviously going to have an implication on how we treat this. Because if an underlying condition is causing the insomnia, we need to treat that first to see if the insomnia subsides as a result. Or simply, it can be down to drug or substance abuse, the insomnia. OHAYON and ROTH in 2003 conducted a study with 15,000 Europeans and found that insomnia more often preceded rather than followed cases of mood disorders. So it came before the mood disorder rather than after. So this means in some cases it might be more helpful to treat the insomnia regardless of whether it's a primary or secondary effect. So even though an underlying medical condition may be causing our insomnia, as outlined by PROVINI et al. In the secondary insomnia explanation, we need to treat insomnia as a secondary or primary or secondary, purely because it's going to have some negative impacts on the individual's life as a result. And we are going to have a bit of a discussion about that as well in a second. Now, these underlying medical conditions which we need to look at, and yes, even though OHAYON and ROTH have just pointed out to us that we need to be treating it regardless, we still need to identify possibly that underlying medical conditions do need to be treated as a result as well. So other reasons why individuals may be developing insomnia. So for women, it may be the menstrual cycle. For everyone else, high blood pressure. Or even with age. Once you get over 60, you start producing very little melatonin, which means that you stop producing that valuable sleep hormone, and you'll find it more and more difficult to get to sleep. Therefore, it is important that we have the correct diagnosis before we just treat insomnia as a standalone condition. So for us, this is going to be a counterpoint to obviously what OHAYON and ROTH have just said to us, because we're going to say, actually, if we treat these underlying conditions first, then it's going to subside. We shouldn't treat it regardless of whether it's primary or secondary. Now, another explanation as to why we develop insomnia. It may just be simply because we are predisposed to developing insomnia. So what does predisposed mean? It means that we are genetically vulnerable to developing insomnia due to our parents having it and we inheriting the genes for insomnia. So, Watson et al. In 2006, using twin studies, indicates that there's a 50% variance in the risk for insomnia could be attributed to genetic factors. So there's a 50% chance that the reason why individuals are developing insomnia is because of genetic factors. So we need to take this into account when we are looking at the explanations of insomnia. Quite possibly, a genetic explanation is the better explanation, rather than attributing it to underlying medical conditions or hyperarousal, which could also be a genetic factor. Now, Banks and Dings in 2007, why do we love them? Because they are modern researchers. Really start to open this dialogue about insomnia and treatment, because the reason why we need to be treating insomnia regardless of being a primary or secondary effect is purely because sleep deprivation has huge negative impacts on an individual's lifestyle and life. For example, it may surprise you to know that sleep deprivation is associated with obesity, increased blood pressure, increased levels of stress hormones, and reduced immune functioning. So we are potentially going to become obese, and because of sleep deprivation, you're less likely to exercise and consume more calories. So therefore, obesity will follow. As we know with our previous essays with theories of sleep, we need slow wave sleep to repair our immune system to get it working back up to 100%. If we are sleep deprived, our immune system will not function as efficiently as it would do when we have had the adequate amounts of sleep. So what does this mean for us in AO2? Therefore, it's crucial to treat the insomnia if the primary condition is causing sleep deprivation, as it can have other impacts on an individual's health. So we need to be treating it regardless. We need to be following that OHAYON and ROTH sort of mentality behind it. However, we do need to look at the explanations. Could it be poor sleep hygiene? Which now, if we're looking at it, it could be purely a genetic explanation, as we've previously mentioned within this essay. Now, the next portion of the essay that we'll be looking at is sleepwalking. Now, sleepwalking falls into an interesting category of parasomnias. Now, for sleepwalking, it is more common within childhood. So, 20% of cases of sleepwalkers tend to be children, whilst only 3% are adults. And this statistic is found by Hublin et al. In 1997. So, it only occurs during slow wave sleep, so non-REM sleep, and is often related to night terrors. So, this is due to the individual acting out there, obviously, what's happening in their dreams. The main part of sleepwalking is people are not conscious and later have no memory of them moving, etc. Now, when we talk about moving, there are various definitions of this, and they are seen through various textbooks and various online sources. Now, in the terms of parasomnias and in sleepwalking, they categorise it as getting out of bed and moving to rustling the bed sheets violently at night. So there are various definitions as to what sleepwalking actually entails. Now, for sleepwalking, there are two main explanations for this. They are incomplete arousal, which is seemingly genetic, and then we've got more common in childhood because they have more slow wave sleep. Now, these are our two explanations, and we're going to have to choose between the two, which provides us a better understanding as to why individuals sleepwalk. Now, in this portion, we're going to be looking at incomplete arousal as a result or an explanation for sleepwalking. Now, this is AO1 and AO2 all in one here. So, EEG recordings during sleepwalking shows a mixture of delta waves plus beta waves from the awake state. Now, sleepwalking occurs when a person in deep sleep is awakened but arousal is incomplete. There's a high likelihood, the reason being why individuals have done this is because it is genetic. So they are unable to completely awaken out of that sleep state. Now, let's see if we've got some evidence to support this. So brought in 1968, sleepwalking in the first degree relative makes you 10 times more likely to be a sleepwalker than anyone else in the general population. So, the sheer fact that if a first degree relative, such as your mother or father, are sleepwalkers, you are more inclined to be a sleepwalker yourself. So, really demonstrating that actually this incomplete arousal might be quite a good explanation. And the fact that we've got some good evidence here to start to demonstrate that sleepwalking is a factor or result of genetics. Now, Lacendre et al. In 2003 found a 50% concordance in MZ twins, whilst only 10 to 15% in DZ twins. Now, what does this mean for us? We know that a high percentage in terms of MZ twins, or high concordance rate, means that it's a likelihood that this is because of genetics and because it is inherited. Now, really for us, this is showing that this is a good explanation. We've got sound scientific evidence here that is demonstrating that with a high concordance rate as well, that individuals who sleepwalk are more than likely sleepwalking because it's a genetic factor. It's a factor which is attributed to incomplete arousal, which is purely something which has been passed down from generation to generation, rather than it being just an individual phenomenon as a result. So, with the statistics that we looked at earlier by Hublin et al., he stated that 20% of sleepwalkers were children, whilst only 3% were adults. So there must be some sort of explanation what is going on here. Now, as we know, it happens in slow wave sleep, and we should know by now, due to the previous essays that we've done, children have more slow wave sleep because they are growing. They need more growth hormone pumped through their body, etc. Now, Oliviero in 2007/2008 suggests that the GABA system that normally inhibits the motor activity during slow wave sleep is not sufficiently developed in some children and this leaves the motor neurons capable of commanding the body to move even during sleep. They found that adult sleepwalkers had signs of immaturity in relevant neural circuits when compared to normal controls. So what is this showing us? That actually this explains those statistics that Hublin put forward to us. That actually the fact that we've got an immature GABA system is the reason why those children are walking, whilst explaining at the same breath the reason why those statistics drop so substantially to 3%, because those children, their GABA system starts to mature, and it's been able to start to inhibit the control of those motor neurons as a result, therefore stopping them from sleepwalking. Now, is this the best explanation? Because it's linking back to statistics. It could be, well, a response to genetic influence as well. To those 20% children, their parents may have been sleepwalkers themselves, which then would make them 10 times more likely to be sleepwalkers as a result. But as they reached adulthood, they entered and their GABA system matured as a result. Now, the EE for this. So this research in adults and children demonstrates that a malfunction to the GABA system could be a cause of sleepwalking during slow wave sleep, because their biological system showed that these particular neural circuits to be immature when compared to normal controls. This supports Olivia Owen's explanation of sleepwalking and would explain how the body is walking around when asleep. This immaturity could allow the motor neurons capable of moving the body, hence the movement. So therefore for us, this may be the best explanation in terms of this particular disorder. In lesson, as an interesting side part that we looked at Scott Falliter and the fact that sleepwalking is being used as a defence in terms of his criminal case. If you are interested in this, obviously use Google, look into it a little bit more, but I did give you a sheet in lesson to look over with this. This isn't included in the essay, but it's just an interesting sideline in terms of sleepwalking. Now, the next part of the essay that we're looking at, and the final part, is narcolepsy. So narcolepsy is when individuals experience fleeting urges to go to sleep, and these are often uncontrollable for the individual. Now, we're going to be looking at the various explanations for narcolepsy in the next couple of slides. Now, the three main explanations for narcolepsy are as follows. So, REM malfunction, HLA system, or hypocretin. Now, for each one of these, we're going to be establishing whether this is the best explanation for the sleep disorder of narcolepsy. Now, the REM malfunction explanation. Now, recent research has linked the areas of the brain that induce REM sleep to narcolepsy. Now, these particular areas of the brain have either become diseased or damaged as a result. Now, the reason why this is an interesting thing is because there are two main symptoms for narcolepsy, which are hallucinations and cataplexy. So, cataplexy is the loss of muscle control. Now, when we look at the characteristics of REM sleep, obviously we are aware that you are paralysed and you dream during this particular phase of sleep. So if this particular area is damaged, and which encourages you to enter into REM sleep, then no wonder narcoleptic patients or individuals suffer from these particular symptoms as a result. Now, we're going to look at some evidence for the REM malfunction. So, Vogel in 1960 witnessed that individuals that suffer from narcolepsy enter into REM sleep earlier in the sleep cycle rather than later on like normal. This could be evidence to support that the areas of the brain that control REM activity are diseased or damaged, and because they are encouraging or forcing the individual to enter into the REM sleep earlier in the cycle as a result. So this would be good evidence to support the REM malfunction hypotheses. Now, Siegel et al. In 1999 further supports Vogel in 1960 and the REM hypotheses through his investigation with narcoleptic dogs. Now, we'll do a discussion about why they might be problematic using dogs in a second. Now, the recordings taken from narcoleptic dogs' neuron activity within the brain stem demonstrated cataplexy is linked with the activation of cells which are generally only active during REM sleep. Now, for us, obviously, this is supporting the REM hypotheses or the REM malfunction hypotheses, because these narcoleptic dogs and the individuals who Vogel witnessed were entering into REM sleep earlier in the sleep cycle are all demonstrating that there may be a portion of their brain which is damaged or has been linked to the creation of their narcoleptic symptoms, such as cataplexy and hallucinations. So this explanation is a good sound explanation as to explaining why individuals are developing or have narcolepsy as a result. Now, for us, the only problem with this research is the fact that Siegel et al. In 1999 used dogs. So within the essay, you can do a discussion about ethics and actually extrapolating the results, because it is highly problematic that we are applying the results of dogs onto humans. As we know, we aren't biologically necessarily the same. Now, for us, there's just a bit of additional support here. So we've got Chakravarti in 2010. Around 1/3 of individuals diagnosed with narcolepsy experience vivid dreamlike hallucinations during narcoleptic attacks. Now, in terms of the REM malfunction, we are starting to say, okay, maybe this is the best explanation, and this is why 1/3 of individuals diagnosed with narcolepsy experience hallucinations as a result. So really, it's adding credibility to that REM malfunction hypotheses as a result, because we are starting to gain evidence to say that these individuals are experiencing these hallucinations and the cataplexy. Therefore, REM malfunction, and we know the features of REM explain why these symptoms are so prevalent within individuals. However, we're going to look at the HLA system and HYPOCRETIN to see whether or not they give us a more sound reasoning. Now, the next part that we're looking at is the HLA system. So the HLA system, as we can see here, we've got very complicated wording, etc. But for us, we just need to really associate it with the immune system. And obviously, what does this mean in terms of the immune system, and why and how it can cause individuals to develop narcolepsy? So obviously within the essay, use what you looked up for homework to increase your understanding of the HLA system. So in the 1980s, research indicated that narcolepsy was a mutation in the immune system. So this is why the HLA system comes into play, because it's so closely linked with the immune system. Honda et al. In 1983 found increased frequency of one type of a HLA in narcoleptic patients. Now, HLA molecules are found on the surface of white blood cells and coordinate the immune response. So there is particular deficiency that has caused the individuals to develop narcolepsy as a result. And this could be a purely genetic reason as well. Narcolepsy and the HLA link is continued to be discussed and researched as a result. It is a difficult area for individuals to really hone down in. Mignot et al. In 1997 found a specific variant that is found to be common within narcoleptic patients and reasonably common within the general population, which, as you can see, has been noted down on the screen there. Now, within the essay, all you need to know is that chunk of information which Mignot has said to us. If you can't remember the variant code, it's okay. Just remember the information that Mignot said as well. Now, what does this mean for us? What does this mean for this particular explanation? Okay, we found this variant. We're finding things which are really demonstrating that the HLA system is possibly a good explanation as to what and why individuals are developing narcolepsy, as it is a response to the immune system fighting off a particular virus or disorder which has been triggered by the variant which is within their HLA system. And because this is activated, they've developed a narcoleptic response. This is possibly a very sound reasoning as to why an individual develops narcolepsy. Recent research has focused down on the hypocretin system. Because the hypocretin system and the HLA system are closely linked to one another. Now, hypocretin, you can also refer to it as Orexian. Depending on which you do, I would say for consistency, call it one or the other. Because it will look a bit messy if you choose one and then use the other later on in the essay. Now, hypocretin plays an important role in maintaining wakefulness. As you can see with the diagram at the top there, if you have less hypocretin, you have less control of sleep. Now, Lin et al. In 1999, this was the first piece of evidence to emerge for this, and it was based on the research using narcoleptic dogs. Obviously, we've done that discussion earlier on about narcoleptic dogs and the reason why it's a bad thing to use to an extent. You can hold that back and use it right at the end of the essay and criticise the use of animals in research. It was found that they have a mutation on gene on chromosome 12 which disrupted the processing of hypocretin. So therefore they didn't have a lot of hypocretin in their system, which made them more inclined to develop the narcoleptic responses. They had less control of their sleep as a result. Now, we're going to start to really discuss this further in a second. Now, the AO2 for hypocretin is Lin et al. In 1999 research has further supported by Nishino et al. 2000, who found human narcoleptics had lower hypocretin levels within their cerebrospinal fluid. So they didn't have a lot of hypocretin in their system, which could be a reason as to why they're narcoleptic. However, Mignot 1998 found that narcolepsy was unlikely to run in families, because he found no concordance when investigating this with twins, which for us means that it's not an inherited disorder, rather than it may just be a individual genetic fault which has made them more inclined to develop the narcolepsy as a result. Whilst Mignot later on in 2001 stated it could be due to other factors as to why we have lower levels of hypocretin, such as diet, stress, or an autoimmune attack. As the HLA system is linked with the immune system, this can explain why low levels of hypocretin may happen. Because we are fighting off a virus, or we're stressed, or we've got poor diet, our immune system may be decreased, which may have a huge impact on the amount of hypocretin that we produce as a result. And obviously for us, this means that the hypocretin, as an example, as an explanation, is a good one, because it's not just solely focused down on one area, it's linked in with the HLA system as well, which means that this is possibly the best explanation as to why individuals develop narcolepsy. Now we have Thanakel et al. In 2000, who found human narcoleptics have an 85 to 95% reduction in the number of hypocretin neurons. So what does this mean for the hypocretin explanation? This supports it further, because we've seen that narcoleptics have such low levels of hypocretin that they're almost undetectable. So for this particular explanation of narcolepsy, of this sleep disorder, makes it more valid as a result. So therefore adding credibility to the hypocretin explanation of the reason why individuals develop narcolepsy. Now, the last point that we're going to raise here, and I think this is the most important part as well, and it really highlights the fact that the hypocretin explanation is possibly the best explanation. So this is a portion of a textbook from the OpenStax College textbooks, which are all available online. What's written here is narcolepsy is associated with reduced levels of hypocretin in some areas of the brain, and the traditional stimulant drugs do not have direct effects on the system. Therefore, it's quite likely that new medications that are developed to treat narcolepsy will be designed to target the hypocretin system. So really, this is the icing on the cake for us. It's demonstrating that the hypocretin explanation may be one of the best ones due to new treatments focusing purely down on the hypocretin system as a result. So for us, the third explanation is the best explanation for narcolepsy, and explaining why individuals develop narcolepsy as a result.